In this video, we are going to be looking at problem 7.3 in your homework. From here on out, we're going to be doing our problems on an Excel spreadsheet or a Microsoft Excel notebook. So you're going to need to make sure you have Microsoft Excel on the computer you use to do your homework, because you're going to need to submit this in as a Microsoft Excel file. So you're going to be able to go on your Chapter 7 assignment page and download this file, and it will look just like what you're seeing here. And if you look down here at the bottom, if you follow my cursor down, you'll see that this notebook for Chapter 7 has 1, 2, 3, 4, 5, 6, 7, 8 sheets, one for every problem. And then the first sheet here is your directions, which we'll go to now. So it's going to look just like what you're seeing here. So you'll just come here and type your name in here, just like so. It's really all you need to do here. And then just when you read down through the directions, the important part here is that you cannot, or do not, please do not try to save this as a PDF, because you will not be able to submit it on Canvas as a PDF. You're going to need to save it and submit it as a Microsoft Excel file. And the other thing is, when you go to the problems, all these cells here that are shaded have formulas. If you follow my cursor up here to this address bar at the top, you can see the formulas. If you go to, like, for example, variance is a really long one. So if you were to delete that, I've not locked these. I've not locked these because if I lock them, you won't actually be able to see the formula. So I wanted you to see the formula that I actually put in here, so you can see what's going on. And but just, as a warning, don't delete these. If you do totally screw it up, you can just simply download the file again from the Chapter 7 assignment page, and you'll be fine. So it's not that big of a deal. Okay, so problem 7.3 is here. So on each one of these sheets, I will always give you the problem. I will give you the equations that are needed to solve each of these problems, and I designed a table here that will enable you to solve them. So the first one, and you're always going to have two. These two are, in terms of as far as the formulas are concerned, they're identical. But the first one up here is for you to experiment with and put in any numbers here that you want, so you can sort of get a feel for what happens and understand how these variables are related to each other and how they move as you change your the numbers that you're putting into your problem. And then the second one is where I want you to actually put the data in from the problem, and so your correct answer should be in this second one. What you do up here, you can do whatever you want up here. This is just for you to learn and for you to sort of get more of a basic a more thorough understanding of what's happening here as we change our values, or as we get different values to work with. And then the one here, you want to put the numbers in from the problem, the second one. So so this is where I'll be looking to see if you have the correct answers. Okay, so I've just put in some random values here, and if you look at this closely, you can see that compared to what you're given in the problem, these sales values are a lot closer. So the mean, or the expected value of this probability distribution, which is simply the sum of the value times the probability, is right here. So this is actually the sum of all this, right? Or you could do this really long thing. I figured out the mean right from here. It's the sum of the value, each of these values times the probability here, and then the sum is the expected value or the mean. So anyway, because these are so close, they're all not far from the mean. So you have a standard deviation of right at $1,000 or a little bit over, and you have a coefficient of variation, which the problem doesn't ask you for, but I put it in here anyway because I want you to look at it, which is right here, which is simply the standard deviation divided by the mean, right here. Now, this is how we define our business risk. The higher this is, the higher our business risk is higher, is what I'm trying to say. Your business risk is higher if the coefficient of variation is higher. And the cool thing about this spreadsheet is we can easily see this happening. So let's say that our possible sales are even more varied than in the problem. Let's say we put in, instead of 14, let's say we put in 40,000 as a probable, or a possible, I should say possible, sale at the high end. And let's say we put in 1,000 at the low end. And let's see here, we put in 20. And here we put in 30. And just see what happens. And you can see that, wow, our business risk goes way up. Our standard deviation went from a little bit over 1,000 to 10,592. But the real thing to look at here is our coefficient of variation has gone up so much higher. Now, even with this really wide variety in our possible sales here, and I should probably put possible, but I keep that as sales because this is what our possible sales are. If we had a really high probability that we were going to be near the mean, so let's say so let's look right now. With the numbers we have in here right now, with these probabilities, we've got a coefficient of variation of 52.2%. Now, if we say there's a lot higher probability that we're going to be near the mean, so if we change this to 90, 0.9, what I'm trying to do here, 0.9, and then we change this to 0.04, or actually let's say 0.001, and say this is because we need 10 more, so this is 0.04, so that's 5 there, and then we'll put, because this has to add up to be 1, so that's going to be 0.04, and this can be 0.101, and you can see that, wow, look, our coefficient of variation dropped from over 50% down to 19% because the probability is so much higher that we are going to be at the mean or near the mean here. So you can see how, depending on the variation in your possible sales and the probability of each one of these possible sales happening, you can see how that's going to have an impact on your coefficient of variation. So it's going to be lower if you have less variation here, and it's going to be lower if you have a higher probability of actually being at or near the mean. Okay, so all you need to do is, and you guys can play around with this all you want, but just to make sure you know that these probabilities, whatever you plug in here, needs to add up to be 1. So 9, and then this is 0.45. So that's 1, right? So, you know, make sure that if, you know, whatever you put in there, that is, you know, that's 1. And now the one below it is where you need to put in the possible sales and the probabilities of occurrence from the problem. And if you put these in right here and here, you will get the correct answers down here, and you'll be fine. Okay.